name's Tony Tauber from Comcast Network Engineering Department, and I'm here today to talk to you about our deployment of RPKI route origin validation. So here's what we'll be going over today. Spend quite a bit of time on the background of our decisions related to route origin validation, and then dig into some more details about validating and publishing ROAs. So, when thinking about BGP security risks, what are they? It's been talked about quite a bit. The biggest one is misconfiguration, people fat fingering or doing typos in their configurations that are caused either misoriginations, aka hijacks. But if it's just a naive mistake, I wouldn't necessarily call it a hijack. But then there are also malicious actors out there. Can't discount that totally. And what are the risks that traffic doesn't go to the wrong place, doesn't go to the right place, or even actually goes to the wrong place? Enter RPKI route origin validation, or ROV. So what are these acronyms? So RPKI, that stands for Resource Public Key Infrastructure. That's the system that makes these things possible. ROA, and we'll dig more into that. ROAs or ROAs are route origin authorization, and they're the main things that we'll be talking about today. And then route origin validation, which is the process that having all this stuff enables in BGP. What does it do? It provides a method for the owner, let's really call them the registered user of a prefix, to assert which ASN or ASNs are the correct originators for that prefix. And then implicitly, that means that the other originators are not valid. What is inside of ROA? It's a signed statement consisting of a prefix, an IP prefix, could be IPv4 or IPv6, a maximum prefix length that we'd expect to see for that prefix, and the originating ASN that we're expecting. RPKI also has some other objects to make it work, certificates, manifests, and so forth, and certificate revocation lists, but we won't get too into those. They're out there though. How does it work? Okay, so the root assigner of all IP address space for both v4 and v6 is IANA, the Internet Assigned Numbers Authority. From there, they delegate it to the 5 regional internet registries, or RIRs. ARIN here in North America, RIPE NCC covering Europe, APNIC in the Asia Pacific region, LACNIC for the Latin American area, and AFRINIC for the continent of Africa. Those entities assign further to what we call local internet registries. Those could be at the country level, like in China or Brazil. They could be service providers. They could also, the RIRs assign also directly to service providers, sometimes directly to enterprises, and so forth. RIR portals for address holders can be used to generate ROAs. And then ROAs are published by the RIR so anyone can view them. There's a couple of different ways that can break down, and we'll get into those details later. But just sort of for a graphic orientation of how this works and what's necessary to get a ROA issued. These are kind of the basic components: the RIR Certificate Authority, or CA, the RIR's resource database, the database of all their resources, IP addresses, and AS numbers, and then the member authentication to their system by their RIR member. Bringing those 3 things together, kind of the basic building blocks of what's necessary to issue a ROA. If we look at this graph that's produced by the US Government National Institute of Standards and Technologies, or NIST, it gives an idea of, and this snapshot is a couple weeks old, gives an idea of the coverage of the current IPv4 address space by ROAs. So we see approximately 1/3 is considered valid, has a matching ROA to what's in the BGP table, and about 2/3 is not found. And then tiny slice is considered invalid. So keep that in mind for what's coming up next. So the backdrop to the to this deployment decision and journey that we're on is that also there's the fail open model. So that means that most of the prefixes are still, as we saw on that graph, still not covered, i.e. they're in the not found category. Hence, the absence of a covering row will mean it will still allow for the route to propagate. And the same holds true for the complete loss of the data by the routers. And I'll dig more into that later, but keep that in mind. So again, it's a fail open model. If there's a if there are failures, packets still get forwarded, and routing happens. The internet still works, which is important for us. Already, some large ISPs have been doing ROV for a couple of years, so that was kind of the part of the backdrop of our deployment decision. So hence, invalid announcements are already getting dropped. So us doing it doesn't, in some ways, dramatically change the world for our customers. So what are the components of ROV? There's the repositories. The ROAs basically are published on servers that are operated by the regional internet registries and their delegates. Then there's the validating cache servers, which are running relying party software, so-called RP software. The validator software fetches the ROAs and other data using a couple of different methods. rsync, which is a TCP protocol for synchronizing files on servers that goes over TCP 873, or RRDP, which is a slightly newer protocol that's specifically designed for use in RPKI. So stands for RPKI Repository Delta Protocol, and it uses HTTPS as its transport. So that's a newer protocol. In some ways, it could be considered preferable. Then the validating caches take that data that they fetched and they run cryptographic integrity checks to produce what are called VRPs, validated ROA payloads. And those are really those tuples of a prefix, a max length, and an origin AS. From there, the servers take that data and they make it available using the RPKI to router protocol, which runs over a couple of different possible TCP ports. And what that allows is that the routers out in the field will fetch the VRP data, and then those routers will cache the data locally and keep checking back for refresh data at configurable intervals. You can also configure it to the routers to retain a copy of the data in case the connection to the cache is lost. So they'll keep their local copy and for some amount of time before flushing it. Thinking again back to our motivation for doing this, taking on this new project. Okay, there's a low barrier of entry. That's kind of nice. There's no new gear because it's just using features on existing routers, and then just needing a few virtual machines running freely available open source software. So it's pretty cheap to implement. No big expenditures. There's a risk of doing nothing. So if we don't embark on this whole journey, we could be vulnerable to misorigination by others of our prefix space. That's not good for our customers. There's risks of doing something. We could do it wrong. We could introduce some collateral damage. There's increased complexity, and there's new troubleshooting, new things to consider when troubleshooting. So those all figure in. Given all these, presenting it to management to get their buy-in is important. I can't just say, wow, there's this new cool technology. We should just do it because it's going to be awesome. And, just take my word for it because something goes wrong. It's going to, end up being whose idea was it to implement this new thing? And that's not that's not where I wanted to be. So you gradually over time getting more awareness. And this, took a couple of years generally to, kind of keep briefing them on this new technology. Things come up in the trade press about different routing security incidents, and that kind of helps make the case of why this might be something to take on. So when thinking about RPKI, there's two parts that I call, I like to break it into reading and writing. And on the reading side, there's validating, and then on the writing side, there's publishing. And so thinking about it, there's the validation of ROAs, and then the publishing of ROAs about our own address space. So when breaking down the problem and thinking through how we're going to undertake this thing, that helps me think about it, and you can really do one without the other. It's not necessary to do them together, and you can do one and not the other ever. You could do them in any order. It's not they're not linked per se when you're thinking about RPKI implementation for your organization. But when thinking about it, the whole plan needed to work incrementally as possible. Can't sort of do it all at once, turn it on globally. And we also needed to have a backup plan of every step and sub-step of the overall project. So this kind of helped me think through the what was needed. So on the publishing side, we decided to, there's two different options, which I'll go into more. But in one case, the hosted model, the RIR, publishes the data that members enter in their portal. For instance, with Aaron, they call it Aaron Online. And then there's the delegated model, which means that the RIR delegates to a local internet registry or other entity, who then has to run their own certificate authority and publication point servers. And then there's the validating side, which is I'll get more deeply into in subsequent slides. Breaking it down a drop further, when we want to think about route origin validation, that's the high-level plan. Okay, we're going to do the reading using published ROAs, and what that means on the ground is add an inbound route policy to drop what we hear from BGP, external BGP neighbors. In our inbound policy, we added it after dropping the so-called bogons, the reserved address space and so forth. We did a field trial with a subset of interconnection partners starting in August 2020, and kept rolling that out through the remainder of 2020 and into early 2021. On the writing side, publishing ROAs for our own address space, we started with a small number of prefixes and gradually expanded. That was mostly done in early 2021. Okay, so what's our deployment environment? We've got Cisco and Juniper edge routers, so we could roll out incrementally. And then for publication, we've got 100 odd prefixes, something over 100, less than 200. And those are spread over 24 internal ASNs, and really have thousands of more specifics BGP announcements when you get down to it. So that was kind of the backdrop of the whole project. Okay, so talking a little bit more about the validating and how we ended up doing it, what went into it. So again, it's easier to do with small risk because it fails open, as I talked about. If there's no ROA, the BGP route is accepted, traffic keeps flowing, and so forth. What we wanted to do was apply it only to external eBGP sessions, not on sessions among our different regional ASs, for instance, even though those run eBGP between them. We're not going to do it on iBGP because I can't think of a way that would even make sense. and something to think about is we carry many more specifics internally. That's probably true of a lot of networks, including ones that are originated from private ASs, which don't get seen by the outside world. So, there are ways that maybe you could undertake to do this, but for us, it didn't make sense to bother with all that. The configuration ends up being per router and per neighbor. So as we were rolling out incrementally, it was easier to see if something goes wrong and to back it out if necessary. So it was kind of like a one step at a time, crawl, walk, run. Sometimes people describe it that way, process for us. Now, pairwise coordination with all the different neighbors that we have is not the goal, but we wanted to notify them. So, right, it's not necessarily like you have to tell somebody, okay, get your BGP person on the phone at such and such an hour, and we'll get our people and we'll deploy the configs, and doing that would really be a very time-consuming coordination process, and really we didn't think of that as necessary, especially given that a number of the other networks had already enabled it on their side. An important key component of all this is the validating cache relying party software, or RP software. So the way that I kind of thought about this was, after considering for a while, okay, what are the necessary properties? We want to have geographic diversity. So we'll deploy it to two different data centers in case one of those has an outage. And then also software diversity. We want to get two different code bases because there were a number of available open source options, but we wanted to have more than just one because the software was, and maybe to a small extent still is, still maturing. And so in case one of those code bases had a problem with those packages, we could just disable it and sort of keep moving with no interruption. So our initial choices for this were, for the software itself, were the RIPE RPKI validator version 3, which was written by RIPE NCC in Java. During the time that we were deploying, I guess it was mid-2020, 2021, RIPE declared they were going to stop developing it and not keep patching software problems or anything like that. So we ended up switching over to use a different package called RPKI client that has a web wrapper, and then another sort of separate component for the RTR servers that's called Stay RTR. So, and then the other package we used was RouteNator, which comes from NLNet Labs, and it's written in the Rust programming language, and that's kind of an all-in-one validator and RTR server. So again, RPKI client does the validation, Stay RTR does the RTR part. But we have these two packages, and hence each router would have 4 different RTR servers configured. For our situation, we were able to find a home for managing those servers in the software with our DNS staff, because organizationally that made sense for us. They were in the same network engineering organization. They had experience with managing servers and software with high availability. So it made sense for us. The networking department itself, the sort of classical, router jockeys, we manage routers, not so much servers. All these software packages we have now, both the RPKI client web and RouteNator have, packages like for Yum or other Linux distributions, Debian distributions. So they're pretty easy to install and keep updated. It doesn't, it's not so onerous. And they can also produce metrics for consumption by telemetry systems to show pretty graphs and stuff. Here's a kind of notional picture to get oriented on how the system is set up. On the left and right, we've got a pair of validators, and call them the East and West data center. At the top of the picture, showing a bunch of different repositories that exist out on the internet. So those validating cache servers fetch data from the repositories using rsync and or RRDP, and then they do their processing. And then at the bottom of the picture, they make inside the backbone, they make or the network, they make the resulting data available to the routers, the PE provider edge routers, via the RPKI router protocol. So that's just kind of gets you oriented on the data flow. What about bugs? Okay, ROV has some bugs. Juniper and Cisco both had some, just worked with our support folks to get the recommended versions. The RP relying party software also had some bugs, mostly bound checking and so forth. As fixed packages were released, we installed those. So no big deal. All right, let's just get into the last part, which is the publishing of the ROAs for our address space. Two different models, right? There's the hosted model I kind of alluded to before. That's via the registry portals. There's varying degrees of ease and integration with using those. For example, some of the RIRs make it easy to take a look at the global BGP table, look at the matching for your address space, look at those BGP announcements and just say publish ROAs that match that, assuming that those are all correct. There's also APIs available. For instance, Aaron had Rich Compton from Charter Communications published a script called that makes use of the Aaron API, and it's not really that polished, but it was very helpful for us and really wouldn't have been possible given what we had to do without that. So much appreciation. Then there's the delegated model. In that case, the address issuing authority delegates to the users. In our case, RIRs, but you could be more layers down, below, say, a country level registry or so forth. And then that authority issues you a certificate, which is used to then sign ROAs and other things. And then that also hosts a record with a URL to the publication point where to fetch all the stuff. So there's two different software packages that can be used for running your CA and publishing, Krill from NLNet Labs, and then one called RPKI.net from Dragon Labs. Something to keep in mind is that publication point to fetch all those ROAs while the validating caches out on the internet, it needs to be globally reachable. And there's some slides here that someone else made that might help one think. They're a couple of years old, but they might help you think through whether or not you want to run your own certificate authority. So when we thought about it, okay, hosted versus delegated. Delegated has extra servers and software. Availability is a little bit unknown. And if we go with the hosted, we have less of these risks. So we share fate with all the other people, say using Aaron, but we might consider it at a later date. There's also some IRRs starting to offer what's called a hybrid model, where the CA is run by the delegated entity, but the publication point is hosted elsewhere. And that might be an appealing way to go at some future point. So when we think about publishing and creating our ROAs, there's potentially larger risks, like you can create connectivity issues if we do something wrong and something goes unreachable temporarily. It can take time to back out or correct the situation, because the ROAs, if you want to issue a corrected ROA or remove a ROA, it takes minutes or hours. So I wanted to make sure to do it carefully. And our situation again was something about 100 plus address blocks. Almost all of those were from Aaron, a few from other RIRs, but they're all over these 20 odd different ASs. Our backbone, our regional ASs, our data centers, our enterprise networks. So issuing a ROA for the largest blocks makes all the ROAs underneath invalid. So it's important to keep in mind. Unless there's a more specific matching ROA already, it's going to create a reachability problem for a whole bunch of your networks. So our approach was to gradually roll out, sign a few non-intrusive prefixes, start at the bottom with the more specific prefixes, gradually fill those in before issuing ROAs for those top level largest blocks. It ended up being several thousand ROAs. Mostly of those were IPv6 because even though there's fewer top level blocks, there's so much more fragmentation you could do potentially with those. But luckily, it ended up being a success with no real issues caused. And that's all I have to say. So my name's Tony Tauber again. If you want to reach me, I'm not going to put my email, but it's my first name _ my last name, Comcast.com. So don't want to get more spam from robots. And hopefully we've got time for a few questions. Thank you very much.
Hi, Tony.
Hello.
Tony is joining us from Boston. Is that correct?
Yeah.
Excellent. Okay. We have one online question right now. Oh, got 2 and 3. First one is from Dylan. You mentioned you hit bugs in the validating software and the 2 noses you've deployed. Did any of those bugs result in making a valid or unknown prefix invalid? What was the impact?
Right. The bugs in the validator software actually weren't things that we saw. It was more like things that were reported or found by developers or or other people. So I didn't have any. We didn't have any issues with things becoming improperly valid or so forth. That wasn't actually a problem that we had. So luckily, yes. Lucky for us.
We have one from the floor here.
Hi, Chris Woodfield with Twitter. This may have been covered in Doug's talk, but in case it wasn't, the invalid prefixes, the ones that are being invalidated and you are dropping, have you had a chance to take a look at the nature of those and find out if those are simple misconfigurations or if there's actual malicious advertisements going on there?
Frankly, no, we haven't bothered to dig into it too deeply that way. I guess, that stuff might come up, but I mean, in the realm of BGP, debugging people's BGP announcements on the internet, I found that you could really spend a lot of time doing that if you want to try and debug everything that's going on in the world, and why it's happening and who to get in touch with about it. Unfortunately, it's too many other things to do.
All right, thank you.
All right, we have some more online questions. This comes from Tony Lee. Why would an otherwise responsible AS intentionally inject a whole lot of invalid prefixes?
Why would they intentionally inject?
Yep.
Well, I don't know if anybody is seeing some invalids from us. I did find there are some places where some external vantage points like route views are seeing some. They are things that are covered by valid prefixes, so I don't think there's an operational issue with them. But some people give route views some kind of unfiltered view, and we may send some more specifics to a few places. So I don't know if that's what's behind the question. But
I have one more from the floor here.
Doug Midori, Kentic. Hey, Tony. I have a question. Forgive me if I missed it. So a row has got two parts. It's got the origin, but it's also got the max prefix length.
right.
So do you have a strategy around max prefix length? Because I feel like there's been a couple of instances in the past, notably in my mind, the Verizon Allegheny Cloudflare leak, June 2019, where had Verizon been filtering based on max prefix length, that would have saved Cloudflare in that case. But also the lesson learned is that your max prefix length needs to be an exact match. Otherwise, the route optimizer could inject some more specifics.
Right.
Do you guys do that? Do you guys exact match, or how do you handle that?
Yeah, thanks for the question. Yeah, we take the advice to just make our ROAS an exact match for the prefix that we intend to advertise. Right, so people have talked about, oh, well, what if I want to, send a bunch of more specifics at some later date, but I'm not sure. I mean, luckily there's automation to take care of that. So if you are doing it as part of some plan, it doesn't take too long to generate and inject the rows. I mean, it does take a little while for them to propagate, like I said, on the order of some minutes to hours. But it's not worth the risk, as you suggest. If some malicious actor comes along or unintentional thing with a route optimizer injects a bunch of more specifics underneath your larger announcement, those get those show up as valid to people. I mean, obviously the origin AS has to match, but those show up as valid and people can, traffic will get misdirected to the wrong place. And that's obviously not what we want. So that's what our approach has been to do it exactly.
But in short, the engineering overhead or the cost, you can solve it through automation. Because I think that's been a pushback. I've kind of argued that you really need to do an exact match, otherwise you're going to get a route optimizer mess with you. Then the pushback is, all right, well now you've limited your engineering ability, because now you've got to keep not just routing and state, you got to update all the ROAs every time you change routing. These things have to be identical, but you're saying this is solvable through automation.
I think so, yeah.
Great.
Thank you, Doug. I got one more online, or two more online questions. Matt Peacock says, thank you for the talk, Tony. It sounds like you began dropping invalids from peers before you generated and signed ROAs for your own prefixes. Can you talk a moment about what drove the decision to start filtering others before first getting your own house (prefixes) in order with ROAs?
Yeah, good question. I mean, I definitely thought about this for a while and had that kind of, thought about it in those sort of ethical, in those ethical terms that you are using, similar type of terms. And I don't think of it that way, I think for me, the real breakthrough, or a real breakthrough was, as I kind of tried to drive home in the talk, is that the two things aren't related, I mean, people can say, cast it that way, but it's not required. I mean, I know of at least one sizable network that has, ROV, no ROAs, whatever life goes on. I think it's useful for them, and it does create a level of protection for the internet. So that's the ultimate goal. I don't think it's necessarily like making some kind of statement about your virtuous behavior necessarily, but the ultimate goal is better, more stable internet for all of us.
One last question here from Andrew Smith. Did you use Aaron's OT&E environment for testing, publishing ROAs, or did you jump straight into production? When publishing ROAs, did you employ any kind of sanity check to make sure that the ROAs you were creating didn't contradict your currently advertised routes?
So I did a tiny bit of experimentation with the OT&E environment. Didn't end up testing sort of everything with it, but it did help with getting a bit of comfort to, use the script that I mentioned to publish a ROA, make sure that I could see it in my validator. Also, if you want to use that environment, you can add a trust anchor for it to your validator software so that you can pull in the information from the OT&E environment. That's a test bed, an Aaron test bed. I guess I should have backed up to say Aaron has a test bed, OT&E. I can't remember what it stands for, but online testing and evaluation or something like that. And so, yeah, I did do a little bit with that to get a sort of sense of comfort with it and understanding what the different pieces were and that I could sort of control them. And then as far as sanity checking to make sure I weren't contradicting my advertised routes, yeah, did do that, but it didn't involve, I'm trying to think, how did I do it? I mean, looking at different external vantage points, be it route views, RIPE, Hurricane Electric's BGP viewing infrastructure is pretty useful. It's not foolproof, but those kind of things. Looking at outbound advertisements. Actually, that was another thing taken for different neighbors, like dumping using CLI commands, outbound scripted CLI, outbound announcements, and making sure that we were covered with all those. And I had some other internal scripts that I wrote to kind of help compare those things.
Here's our last question, Tony. Follow-up from Tony Lee. Pardon me. The NIST RPKI monitor shows that several ASs are getting both valid, not found, and invalid prefixes. Have you investigated it at all?
Yeah, so thanks, Tony, for that question. So, Bray, exactly, that's the thing I was kind of referring to, which I thought maybe you were getting at with the earlier question. So yeah, I did follow up with that and talk to the folks at NIST, and they were able to direct me to where they were getting that. And as I said, I think it's it's coming from some route view, one of the route views monitors and one feed that's going to it. Yeah, so I did look at it and I talked to them also. I mean, they do have an indication in their excellent website of whether or not it's covered by whether an invalid is covered by a valid, so that it's you can get a sense of whether it's going to have an effect or not create a eligibility problem. So I wouldn't necessarily call it a totally cosmetic problem, but I think I have a good handle on what's happening with it and that it is causing a functional problem. As far as not found, yeah, we advertise not found prefixes for ones where there's address space that is on behalf of our customers. That's not our own address space. I mean, we want to encourage them to issue ROAs, but we're not. That's more of a socialization thing and training. So I'm not totally there yet.
Excellent. Well, Tony, thank you very much for joining us live from Boston, Cambridge. And get a round of applause for Tony.
Thanks,